Hello, welcome to Math for Today. Okay, so hopefully the review went well for you guys, which we just went over. I want to show you that really tricky question, which was the stretch your thinking. Now, crazy enough, I don't know why that's in there. If you're thinking, oh my goodness, this is gonna be something like we'd see potentially on a quiz or a test one day, no. Yeah, I always wonder why they put that one in there, because that question is actually grade like 8 math, not even grade 7 math. So I'm gonna show you guys how to do it, just like kind of quickly. Okay, so here we go. All right, so this is like really, you do not have to take notes on this at all. But there might have been a few people out there who were like keen to kind of try to figure this out. Okay, so we're not gonna spend too long on this though before we go on to like the main part of the lesson today. Okay, so, all right. Okay, so if we look here, okay, so we're drawing this. I went over this already. Okay, right, so this would be figure number 2, and then figure number 3 has 4, right? 3 and then 4. Okay, so anyway, we know what's happening here is we are multiplying the previous number by 2, okay? Multiplying the previous number, so 2 times 2 is 4, and then 4 times 2 is 8. So that's what's happening. So then what we could do is continue this pattern. Okay, so that's probably going to just be like the easiest way to do it. I'm going to show you guys how to figure out the expression in the next slide. Okay, this question is like especially wonky because they start with like this kind of like, this makes it difficult to determine the pattern rule at the beginning of this, but I'll show you how we make up a pattern rule for a similar type equation next. So what we would basically need to do here is just continue, right? You could use your calculator for this. So we would know that 8 times 2 is 16, 16 times 2 is 32, and then this is going to be 64, and then what it's going to be next, 128, I think, right? What are we at? 5, 6, 7, 8, we have to do 2 more, 9, and then 10. So you might have to get out your calculator here if you want, or I guess we could also do this by hand. So 256, and then we would do 256 times 2 is 512, okay? So that's the answer for the first one if you just continue the pattern, 512, and then we're just gonna keep going. So I'm gonna use my calculator. 512 times 2 is 1,000, so this was 10. Okay, and then 11 is like 1,000 something, so I'm not there yet. Then I'm gonna go times 2 again. This is 2,000 something, and then I'm gonna try 13. So times 2 again, this is like 4,000 something, and then I'm gonna guess again. So this was my 13th try. And then I'm gonna guess again, probably it's gonna be my 14th try, because this is gonna be something in the 8,000s. Times 2, yep. 892. So the answer for this one is 14. Okay, so you probably could figure that out. More difficult to come up with the actual expression though. So there you go. If you were curious to do that one, there's how to do it. Okay, now this is basically, you don't have to write this down. This is just like what that actual previous one was. It's actually a non-linear equation. So you're gonna hear these terms when you get to grade 7. Oh yeah, we're doing linear equations. And a linear equation is essentially when we have, let me find my grid. Yeah, so when we have a grid like this is our notes from yesterday, and a linear equation is when a line, linear, right, line, root word, is created on the graph that just goes in a straight line. However, if we were doing this one, notice how it gets crazy fast. So this graph, if we were to graph this, it would look something like this. And that is a non-linear equation, which is much more difficult to determine the expression for, which is why that's saved for later math. Okay, but if you were curious about doing this one, I'll tell you how to do it, which is kind of cool. So we have to look for a pattern in the output. So I've changed the question a little bit. So here's the output. Okay, we know that it's always increasing by 2. And then how does it relate to the previous value? Okay, again, it's multiplying by 2. The solution is, okay, 2 times the previous value. But this is the cool thing. If we wanted to figure out the expression, basically what's happening here is we have 1 times 2, which is 2. This one, we have 2 times 2, which is 4. In this one, now the figure number actually tells us how many times we are multiplying by 2. So the first one we multiplied by 2 just to get 2. Next one, 2 times 2 is 4. The next one, we're doing times 2, but we're doing this 3 times. So 2 times 2 times 2 is 8. Okay. The next one, because 2 times 2 is 4, and then 4 times 2 is 8. The next one is 2 times, we have to do it 4 times. 2 times 2 is 8, times 2 again. 2 times 2 is 4, and then 4 times 2 again is 8, and then times 2 again is 16, okay? So if we were to do this again, if I was to make up 5, then it would be 5 times 2, okay? Now, this is the cool thing. This is why this is not grade 6 math. This is more like grade 7 and 8 math. But really what's happening here is we're doing exponents. So 2 to the power of 1. We've multiplied 2 by itself only one time to give us 2. If we have 2 raised to the power of 2, that gives us 4, which means that we've taken 2 multiplied by 2 times. Then this one, it would be 2 to the power of 3. So the exponent, this means how many times you're multiplying it. And then this one would be 2 to the power of 4, meaning that we have multiplied 2, 1, 2, 3, 4 times. If we were to do this one, 2 to the power of 5. So if you want to type this into your calculator, you could, and this is what you would get. So the expression for this, math geniuses, is, what are we noticing? Figure number, right? Figure number, I'm going to call this maybe n, okay? Where do we notice that our n is? Well, it is, boom, right here. So we know we have to have an n in our expression. So the n I'm going to put here. And then this is your expression. 2 to the power of n equals y. Or 2 to the power of x equals y. Whatever you wanted to make it. Y being our output, which is the tile. So I could have said 2 to the power of the number of figures we have equals t, if that represents tiles. Okay, whew. When you get to this in grade 7 and grade 8, you're gonna say, we already did a little bit of this in grade 6. Your teachers are gonna be blown away. They're not gonna be able to believe you already talked about this, but this is not going to be anywhere tested. That's why this question that they gave you was like kind of crazy, because it's like, again, it's this like non-linear equation. And this, interestingly, is kind of what is happening with COVID, right? They're trying to track the trends to see it's not going up. If you were to look at the graphs, you're going to also notice that it's increasing exponentially. That means it's not being added, it's being multiplied. Okay, cool. All right, here is our actual stuff for today. All right, creating graphs. So, alrighty, so what we're doing, basically, okay, we're working in the opposite direction. So if they give us a graph, we have to work in the opposite way. So I've just drawn this one. It could be anything. So the first step is, I'm just going to go through these steps first, and then we'll go back and do the example. So step number 1 is label the ordered pairs. Okay. Number 2, and I do suggest that you sketch this. Like if we were in class, I'd give you this little thingy, but just take a moment. You can pause me and then sketch this. The next thing is we create a table using the ordered pairs from the graph. Then we find the pattern rule. Okay, but I think actually today we're not going to find the pattern rule. We're just going to stop at creating the table. Okay, so, alrighty. Okay, so I'm just going to make a table here. And I'm going to include, whoa, why am I still on this? Draw. I don't want to draw anymore. Okay. So my table, whoa. Okay. Alrighty. Okay, fine. I'm just going to go down here. Okay. So my table, I'm going to name this as the X axis. This is going to be called the Y axis. And this is going to be called ordered pairs. Okay. So my X axis, if I'm labeling this, my first one would be, well, maybe I'll do my ordered pairs first. 1, 5, right? This one falls at 1, 5. Then the next ordered pair I have is 2, 3. Then my next one is 3, bracket 3, 1. Okay. Then working backwards, we know that the first number is always the X and then the second number is always the Y. So 1, and then this would be 5. 2, 3, 3, 1. Okay. So there you go. That's actually basically it. That's basically all that you have to do for today. Is just that. You're going to create the table. Sometimes they're going to ask you to do the table first, then make the graph, or maybe they're going to give you the graph and they're going to say find the ordered pairs from the graph. So that's actually it. This is your homework for today. It's just page 31, questions 1 to 3 in the textbook. Okay, I'll show this to you. Oops, not that one, this one. Okay, so yeah. Oh, it does go on to page 31. Okay, yeah. So page 31 to 32, questions 1 to 3. Okay, so this is super similar to the one that we've done before. So record a table, record each pattern in a table. So you have to make up the table. And I do suggest that you also make up, they don't tell you to do this, but this is like my secret tip, is making up this section here for ordered pairs. Okay, so you can probably figure this out, but then the new thing that we learned yesterday is making up this part for the ordered pairs. Okay, so that's kind of like the background magic work behind this. So this one, you can probably do that. And then you need to draw the graph. Okay, so figure out the ordered pairs and then draw the graph. Okay. Yes, you know what I'm going to say for this one, if you want to do you can choose 2 of them. You don't have to do A, B, and C. If you want to push yourself, you can, but I'm going to say you can choose, choose a, you know what I mean. Okay, so anyway, I'll just say it. Yeah, so there you go. You don't have to do all A, B, and C. You can choose the ones that you want to do. The next one, you have to, again here, you have to use grid paper, create graph each table, describe the relationship shown on the graph. So describe the relationship shown on the graph would be what we did yesterday, which is as the input increases by 1, the number or the output increases by whatever. Okay, that's what they're asking. Then you do need to draw this. So I would suggest, again, you have to make that sneaky third column. And then the next one, yeah, make a graph for each table. So that was basically like what we just did today. Okay, that's all you have to do. We're not going to do expressions quite yet. Okay, so, one more thing that I forgot to say. I've made a new thing on Prodigy, okay? Yeah, okay. Okay, I need to show this to you super quickly. Okay. It's about this exact stuff that we're doing. If you need your password or whatever, message me. Oh, cool, you can play against someone. Sure. Okay, I'm just gonna show this quickly. Okay, so go wherever they're pointing. You'll see I made a whole new task. Doesn't matter, just click on anyone. Okay, see here? Same stuff. So which graph represents the pattern rule? Start at 19 and then subtract 2 each time. So which one shows that? This is so good. If you're not sure, you can click on this and it's gonna give you a little hint for what we've been practicing. Okay, so, whoops. Okay, so there you go. Yeah, I'm not gonna continue playing that, but you guys can. So this I've made live starting from today, and then I have it closing I have it closing on Wednesday. So you have like today, tomorrow, and Wednesday to do it. It's not like a test, it's just like practice stuff. Yeah, and it's good for you to do. I think this will help what we're doing in class. Okay, so see you soon for, have fun with your homework. Hopefully you're able to finish it, and then we'll see you for ELA pretty soon.